Okay, welcome to the third video on factoring quadratics where a is equal to 1. Okay, again, a is equal to 1. Why is that? Because right here in front of that x squared is a 1. And the reason that these are a little bit easier to factor than the stuff we're going to do in the next lesson is that we know, because that's 1, the only way to get that x squared, right, is if we multiply two binomials with an x and an x in front. Okay? If that a is not 1, then it becomes a different type of problem, which we're going to learn next. Okay, so for right now, let's stick to what we know. We're going to make our x. We're going to put our negative 45 on top. And we're going to put our negative 4 on the bottom. Now, if you notice on this one, we're looking for what times what equals negative 45, but when we add them equal 4. Okay, so again, we know 1 is going to be positive and 1 is going to be negative because that's the only way we can multiply two things and get a negative and then add them. And since I'm left with the negative, I know the negative needs to be the bigger of the two numbers, right? So what are my factors of 45? Well, let's start with a couple that we know right out of the gate. We know 1 and 45 are factors. 45 plus 1 is 46, and 45 minus 1 is 44. So we know that's not 4. But then some of you might have jumped right to it. We also know that 9 and 5 are factors. 9 times 5 is 45, and 9 minus 5 is 4. So which one needs to be negative? Well, we need to be left with a negative 4, right? So when we add these, the bigger one needs to be negative. Negative 9 plus 5 is negative 4. Negative 9 times 5 is negative 45. So I've solved my puzzle. I have negative 9 right there. I put my 5 right here, which means I can come back and I can finalize my binomials with those two numbers I found. And I'm done. Okay? Remember, this is the backwards process of what we learned on our last test, right? So we can always check our answers. We can always say x times x is x squared. X times 9 is negative 9. 5 times x is 5x. And 5 times 9 is negative 45. Negative 9x and 5x is negative 4x. And it checks with my answer that I started with. So if you're good at what we just did, it's almost like you could grade your own work yourselves, guys. Okay? So maybe try this next one on your own. When you're ready, start the video. I'm going to make an x. I'm going to put a negative 20. I'm going to put an 8. What two numbers, when multiplied, equal 20? That I get 8. So I know the 10 needs to be positive, the 2 needs to be negative, and I am good to go with an m plus 10 and an m minus 2. Move on to the next one. Maybe try it before I do it. I'm going to move a little faster on these because we should be getting the hang of this. Put my negative 60 on top. Put my 7 on the bottom. Now, what are my factors of 60? Okay, this one might stump you at first because you've got 1 and 60. You've got 2 and 30. Right? You've got 3 and 20. And eventually, okay, you're going to get to 5 and 12. Okay, you might even have got 4 and 15 in there. Okay, but if you look down here, I'll write it on my list just so we have it. Okay, you might have to get a calculator and start banging away at the calculator trying to just figure numbers that go in, right? We still have 6 and 10, right? So this one has a lot of different factor pairs, and maybe you get it right off of the bat, okay? But notice I didn't put any negatives in yet. I really just want to get the factors listed, and then I want to look at that 7 and say, which one of these numbers, which sets of numbers can I get 7 from? So this is, first one here is 60 plus 1 is 61 and 59. This one is 32 and 28. This one is 23 and 17. This one is 17 and 7. So that one's a possibility. This one is 19. 15 plus 4 is 19. 15 minus 4 is 11. So that doesn't work. 10 minus 6 is 4. And 6 plus 10 is 16. So it has to be some combination of 12 and 5. Well, I want to be left with a 7, positive. So the bigger number is positive. The smaller number is negative. I figured out my puzzle. And I'm good to go. So I have an x in this one. I have an x over here. And I'm done. Now, could I have written the x minus 5 first and the x plus 12 after it? Sure, that's fine. The binomial order doesn't matter, but it does matter that the plus 12 is plus and the 5 is negative. Okay, if you get those backwards, the whole problem is wrong. Okay, the last example here, okay, and I'm just going to erase these factor pairs right here just so we don't get confused that they're part of this problem, okay? And we're going to take a look at this one. We're going to make our x. We're going to put our 10 on top, and we're going to put our 2 on the bottom. And we ask ourselves, what are factors of 10 that when add equal 2? Well, our factors of 10 are 1 and 10 and 5 and 2. There is no combination of 1 and 10 or 5 and 2 that add to be 2. So if you're sure about it, and these are your only factors, then you would write not factorable. So not factorable or no solution would be answers. But we prefer to say that since we're not solving anything, it's really not a solution, right? So I don't want you guys to get confused with that. So this problem is just if I asked you to factor something that's not factorable, you would just tell me, hey, it's not factorable. Okay? So hopefully that makes sense. All right?